Welcome back. We're going to be doing our homework assignment tonight. This was 40 through 72 odds. So let's get started. It said simplify each expression. If not possible, write simplified. That one's simplified. Let's see. I have a z squared and we got like terms. I have a 5z squared and an 8z squared. 5 and 8 make 13z squared plus 3z. Any like terms? 6x and 5x are like terms. 6 and 5 make 11x plus 4y. Let's see, I've got a squared, a squared, a squared. We got three like terms here. So 5 plus 2 is 7. 7 plus 1 is 8. We have 6x squared, 14x, and 9x. Our 14x and 9x are going to combine. 14 minus 9 is 5, so we're going to get 6x squared plus 5x. 50. Like term. 2 and 6 make 8x squared. 52. No like terms. I forgot an E at the end. Example 6. Consider each verbal expression. Write an algebraic expression to represent the verbal expression. Simplify the expression and indicate the properties used. Fun. Okay, the product of 9 and t squared. So I think this is 9t squared. So increased by 3 times the sum of 2 and t squared. All right. Well, our next line is going to be 9t squared plus 6 plus 3t squared. And we use the distribution property. From here, we're going to combine like terms to get 12t squared plus 6. And that was combine like terms. And we saw that with combining like terms, we can pull them apart using distribution. The product of 3a, all right, let's write that, plus 5 times the difference of a and b. All right, our first step is to use distribution. So we get our 3a. Positive 5 and a make positive 5a. Positive 5 times negative b make negative 5b. Combining our like terms. Our like terms are 3a. And wait, first we got to say distribution. Then we're combining like terms to 8a minus 5b. Combine like terms. Shouldn't have done 55. Getting way too into doing math. Next up, 56. 3 times the sum of. So 3 times sum of r and d squared plus d squared. Increased by plus 2 times the sum of r and d squared. Ooh, I see what they're doing here. All right, now something to understand. See how they both have this r plus d squared attached? What you can do is say, let, I don't know, a equals r plus d squared. So this becomes 3a plus 2a. 3a and 2a make 5a. And now that we've added them together, we can pull back in that squared. So 5a, what does a equal? R plus d squared. We used combine like terms. Then we use substitution. Substitution, combine like terms, substitution, and then the last step will be distribution. 5r plus 5d squared. No, that was distribution. All right, moving on. We have to just simplify expressions, so this goes a little bit easier. So this is going to be 4fg plus 12g plus 5g. Like terms are 12 and 5. So this is going to be 4fg plus 17g. 60. Using my distribution, we'll do the distribution on top. That gives us 12x plus 8 plus 7x. 12 and 7 give us 19x plus 8. 62. Ooh. Now, they gave us kind of a mixed number here, but what you have to know is this A over here is on the top technically. So we have A. So what do we have? We have 1A plus A and 1/5 A plus 2/5 A. So this one might seem a little hard to wrap your head around if you're not good with fractions, but the way to think about it is let's replace A with banana. So we have 1 banana plus 1/5 of a banana plus 2/5 of a banana. So it's going to be 1 and 3/5 A. Another way we could write this is we could say 8/5 A. Both are equally correct. 64. Oh, take a look. We can actually do our combined like terms in here first because it's inside the parentheses. So if we do our combined like terms, we get 2, 3n minus 5. Do your distribution and you get 6n minus 10 on the back. 66. This theater has m seats per row on the left side of the aisle and n seats per row on the right. Got it. There are r rows. Okay. Explain how you can use the distributive property to write two different expressions that represent the total number of seats in the. All right. So we could say r, because that's how many rows. And if we ignore the aisle and just think of seats, it's going to be m plus n. The other way we could write this is r times m plus r times n. B, suppose you double the number of seats in each row to the left side of the aisle. Does this double the number of seats in the theater? No, because we're only doing side of it. This is just saying you're trying to make a claim somehow that r, well, it said the left, so that's m, 2m, because whatever m is, we've doubled it, plus n. This will not result in twice as many. Justify our answer? Sure. R equals 3, m equals 3, n equals 2. If we plug this in, normally, so we have 3 plus 2, so this becomes 3 times 5, which is 15 seats. Plugging those same numbers in down here, we get 3, 2 times 3, and 2. 6, 7, 8. So this becomes 3 times 8, which is 24. 24 is not the double of 15. And we proved it by using the same variables in both of them, and we got two different numbers. Persevere. Use the distributive property to simplify this. Ooh, this is a fun one. Okay. So first things first, we got to do that super distribute. Well, no, let's not do the super distribution first. Let's save this on the outside. Let's first care about our inside parenthesis. We can see that this group parentheses and these ones don't really do much, so we're going to drop them. So we have 6x squared on the outside, 3x minus 4 plus 4x plus 2. Combining like terms, we have 3x and 4x. So over here, the 6x, we have 6x squared. 3x and 4x make 7x. Negative 4 and positive 2 make minus 2. So we've simplified the inside parentheses. Now we can do our distribution. 6 times 7 is 42. X, we have x squared times x, that gives us x cubed. And then 6 times negative 2 is negative 12x squared. 70. Determine whether the following statement is true or false. Justify your argument. The distributive property is a property of both addition and multiplication. So it is a property of multiplication, and I would argue that yes, it's a property of addition, but only because addition and multiplication are linked. Multiplication is advanced addition. So we have 2 times, so like any amount of multiplying is just, so like 2 times 3 we know is 2 plus 2 plus 2. We can pull the 2 out front. We get 1 plus 1 plus 1. This becomes 2 times 3. So anytime that, and look, we just had it, here's addition. I used the distributive property and made it multiplication. True. So what we did is we took an addition problem, made it a distribution problem, and turned it into a multiplication problem. 72. Create an expression that simplifies 2a plus 14 using the, that simplifies 2a plus 14. All right, so let's start with 2a plus 14. So we want something that'll simplify to this. So I see 2 right here, and I see this is a 14. They're both even. So I'm going to pull a 2 out front, and then divide by 2, divide by 2. 2 divided by 2 is 1. Carry the a. 14 divided by 2 is a positive 7. So 2 times a gives us the 2a, and 2 times 7 gives us the 14. That's it. Thank you so much.